Okay, let me share the screen and we will start it off right away. I'm able to share the screen, no sure. I'll take that.
Yeah,
Okay,
yeah, we can see that. It's
yeah,
coming.
sure. Thank you.
Thank
Fine.
you. Bye.
Once again, good morning, everyone. Apologize, got a couple of minutes delayed. I just returned. I was on travel, so got a slightly delayed. Anyways, so today is actually the last session, but this session is going to be slightly loaded in terms of the contents that we have because there are a lot of things on the analytics that we are going to be talking about. But before that, a quick summary. As always, what we do. So this, the day one, we started off with trying to understand the importance of data. Where is it coming from? Why is it so much of hype? And then got into specifics on how do I do an analysis, and then took some case studies trying to do that. Then moved on in terms of the impact of technology and how data is being used in L&D. How can we do that? Last session, we got into some metrics related to L&D, saw how it can be plowed back, and we also created a playbook which helped us in understanding how you want to implement it. Now, with all that done, today is going to be why at all do we need all these analytics? And then the moment I say analytics, it is going to be a lot on statistics. So we will talk about some of these statistical tools. Believe me, I'm not going to be doing statistics session here, but I will have to introduce you to a couple of statistical concepts, which I will tell you. And that's why I put that disclaimer at the bottom. Lot of what I'm doing today is only conceptual. It is at a very high level, tip of the iceberg. This itself is going to be a full-blown paper if at all I want to do that. So I am not getting into the specifics, but I'm giving you a perspective so that you will probably be able to understand the nuances around it from a jargon perspective, definitely, and to an extent in terms of what you could probably do. But if you need more detailing in terms of it, I will probably add some references when I send the study material so that when I send my slides, so that you will probably be able to, I'll give you some material around the kind of books that could probably help you out more on statistics or more on creating visualizations and all that. That could probably give you a detailing. But from a course outline perspective, I'm just going to give you a perspective because you're expected to understand the analytics concept. You are expected to know how you will be able to do this. And that's where I'm giving you this. And I'll probably show you some perspectives around how Excel is helping us out in doing it with a live demo in terms of it. So this is what I'm going to be doing. And with this, the session coverage in terms of the classes will be over. All the units will be completed, right? So we will get into the detailing in terms of how we go about doing it in the session. Okay. So why at all are we looking at the analytical tools? Now there are a lot of reasons that comes in, but I've tried to summarize it in these 8 concepts, 8 subheadings. Basically, one is it enables a decision making which is more informed because you are looking at the data and then you are trying to see what it is. So you're no longer deciding based on intuition, but you have started deciding based on what the data talks to you, which is why you are able to provide better insights on your perspectives and assumptions. So you get that competitive advantage. The third angle that you're trying to look at is all of this is not possible if you're not going to automate a lot of things. But once you start doing all this through these automated techniques and all that, you're able to achieve better results at a faster rate. So you will probably be able to do that. So the fourth point that I'm trying to look at here is from a predictions. Now that you have talked about the descriptions, now that you're probably talking about the descriptions, you are also getting into the next step in terms of predictions. You're also getting into the next step of predictions. Now, what do I mean by that? Typically, we talked about it, right? The descriptive, diagnostic, predictive, and prescriptive analytics earlier, long ago, the first session. So basically, you know the description, so you will be able to diagnose in terms of what it is, and then probably bring in some perspectives and then build on it to predict and then prescribe. So you are slowly moving into a situation where you are able to manage your risks better. Now, where is that coming in suddenly? Now, the logic is very simple. Once I know what is in store for me, I'll probably be able to act better. When I drive my car, seat belt is important because in case of accidents, it's going to help you. So you know that there is a risk. So you're trying to safeguard yourself. And that's exactly what we are trying to do here. While that's a very mundane example, the logic is we are able to see what is coming up based on which we are able to get into the specifics on how do I control it. So the beauty of this data analytics, if you really look at it, is it is a lot on collection of data. But once you start collecting the data, you are able to make a lot of analysis using it. You dice the data the way you want it, which will tell you what has been happening. And based on some of these statistical methods, we will probably be able to identify what could potentially happen and see how you can circumvent those so that you achieve what you want to. That is where you're trying to prescribe. So that's exactly where this comes in. And all of it, if I'm going to do manually, it's going to be very difficult. And that's exactly why I start automating things or look for tools that is going to help me in automating them, right? And then once I start doing those kinds of things, the moment I automate, the moment I get into these, the advantage that you will get here is I am able to streamline my process better. I am able to understand. I would probably be able to understand what is happening, and I will probably be able to free up some of the mundane tasks by automation so that people can focus on their expertise. And more importantly, with all these insights, you are now getting closer to the customer. You can plan better. That's exactly what happens in the retail industry with an Amazon or a Flipkart, or that's exactly what is happening in your transportation industry with your Ola or Uber, or in your hospitality sector with your Airbnbs and your OYO rooms and all that, right? They are able to align much better in terms of what the customer needs are. So the essence of the slide, a loaded slide, but I've tried to put it very minimal, is once I collect the data, I will know the behavior patterns of the business. Now, based on these behavior pattern of the business, the moment I say business, remember the first day the session wherein we talked about the four pillars in terms of customer, employee, product, and operations, and then we talked about how data helps in making decisions related to that. So all four factors comes in. So what happens? I know my employees, I know my customers, I know how I can optimize a lot of the operational aspects, and I will implement all those in my products so that I get closer to the customer. I satisfy them, which means the business is successful. So the line that connects all these is the techniques that you use to do it. Now, when you look at, let's say, for example, some five numbers, or when you probably look at 1 to 30, 31, you look at it in a calendar format, you call it a calendar. When you put 1 to 30 just like that, you don't call it a calendar. So that's the difference. Now, the analytics will help us build a pattern which is going to tell us the behaviors and how this can be changed. Just some numbers 1 to 30, 31 does not make any sense to us, but we just call it as random numbers. But the moment we put it into a format like a calendar, we say that's a calendar. So the evolution in terms of a normal number into a formatted output. Just reimagine that in a business perspective. You have sales data, you have your operations data, you have your employee data, a lot of those different types of data. They're all just data. The moment you consolidate all of them and try to bring a meaning out of it, you are starting to analyze. So when you are trying to get a meaning out of the data that you have created, it becomes your description because you are describing what has happened. The moment you are able to describe what has happened, you will probably be able to isolate problem areas and you drill deeper. That's your diagnosis, your diagnostic analytics. Based on that, you know, what was the cause? So once I know the cause, I will try to rectify the cause so that I will say, now with my doing this, I will be able. Now, let's say, for example, a loan processing took 45 days instead of 20 days. Then I realized the loan applications during a particular period is higher, and that time the number of people involved is lesser to manage it, so it takes longer time. So, two parts that I can look at: do I take additional people or automate? What will I do here? I will obviously go for automation because additional people is only for a temporary period. So when I want to automate, what happens? I'm able to compress the time not only during the peak seasons, but also on the other timings. So I'm able to predict the positioning based on which I will prescribe a solution. The solution here is automation. This is how a simple raw data that you are consolidating enables you to analyze and build better business. So that's exactly why we need these analytical aspects. And I call it analytics, just not analytics, but tools. I've been talking about these examples in multiple sessions, but today I'm slowly moving into a tool concept, basically because the volume of data is so high and the speed at which you need is also very fast that it will be very, 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 very difficult if you're not using any tools. And that's where people start looking at implementing the tools. I know I rattled out quite a bit in the last 5 to 7 minutes. Is that making sense? Any thoughts, comments, anything at all that you want to say before I get into the next slide? This is the core of analytics. So I thought I will spend some more time, though I've been talking about it earlier. Anybody, any thoughts, comments? Is it making sense? Okay. So with this, I've slowly moved into the next one where I talked about the description, prediction, and prescriptive. I talked about it. So typically when I talk about descriptive, I focus on what has happened. It's always history. So I will need to report the data through visualization tools. But when I start predicting, I start applying some statistical models for forecasting. Some of the models that are typically used are regression models or write code for machine learning. Prescriptive is basically how do I mitigate the risk so that I'm not going to get into the same problem. Now, what I'm going to be talking about, if you really look at it, is a lot on this descriptive analytics. Maybe if time permits, when I'm showing you the Excel, I will show you how a regression analysis can be performed in Excel, but I'm not getting into those details consciously because it gets into a lot more statistical aspects. And prescriptive is basically the essence of this, which is your critical thinking and your analytical thinking, which will enable you to say what it is. So that's how I'll be covering it today. So again, why tools? Yes, it is the foundation because we are able to apply a lot of things across various things, and raw data to insights is faster and it supports decision making. That is where it comes into. So now comes the specifics. Where do I apply what type of tool? Now, this is very important for us because this is what is going to be the essence of the analysis that we are talking about. Now, descriptive statistics or descriptive analytics. Let's probably see what that means. Now, when I'm talking about descriptive, what is descriptive? You are describing something. So basically, all that what you're doing is certain things have happened. You're trying to describe in terms of what happened. Like, for example, in your sales meeting, the sales team will talk about the various prospects who were met, what happened there, what is the probability of those prospects to become a client. Then they will talk about any of the client meeting in terms of cross-selling, upselling. So basically, what is it? It's a summary of a lot of things that happened in the past. So this is always historical. So some of the tools that we use in terms of it is very simple. When I do a sales forecasting, what do I say? The average sales for the last quarter was N. So this quarter, I had projected n plus 5%, but based on what was there, I will probably make it n plus 7% or n plus 3% or whatever it is, right? So you will probably focus more on average, that is called mean statistically, but there are other tools that, I mean, other measures that could be used like median, mode, standard deviation, or all that. Where will I use this? Basically to understand what is the current scenario? Where am I? That is where I will use this descriptive, because this is going to tell me my current position. This is going to tell me my current positioning in the industry. The second one is inferential. Now, this, if you really look at it, is this inferential. The way I could probably look at it is, though I have given the technical term saying make inferences about a population based on a sample. The logic is very simple in terms of inferences. Now, let's say, for example, you are wanting to roll out a new training program. You are wanting to roll out a new training program. Now, you are trying to bring this up based on some past analysis that has happened on the descriptive system. Now, I will probably take a hypothetical instance. Now, let us say, for example, the organization recently underwent a change. Let's not make it a complex change, but we will probably say a new CEO has taken over. So the way he is trying to look at things is different. So he wants us to plan the targets in a different perspective. So all that he says is, I want to see, I want to revamp the product line. So I want to know which of these products are performing well, which is not performing well. And I want to see if I can introduce new products. So what will you do? You will first talk about a training which is going to manage the change. Then once the change related training is planned, now what will you probably do? This is not a typical change management training that you're going to talk about. Here is a change management training that you're giving to the sales team in alignment to what they want in terms of product. So what you will probably do is you will probably tell them, how do I say a product is working fine or not working fine? And then you will probably get into the specifics in terms of the detailing around this thing. So what I mean here, if you really look at it, is I will make an assumption in terms of where we are to what we ought to do. So a good example of already completed this thing that we talked about is, remember the purposeful analytics 8 steps. What did we say? We first said understand the problem, and then we are asking questions related to the problem. But you make an assumption, this could be the cause for the problem, and then collect data to prove based on it. What are you doing there? You are picking a population, and then from there, you're taking a sample of that population to see whether that is appropriate or inappropriate. That is what we did when we talked about the attended versus nominated, the example that we took in terms of implementing this. We asked some questions. We took some last 3 months data, remember? So though I have been running the organization for last 20 years, I am taking the last 3 months data or 6 months data. So what is my population? It is that last 20 years of data. But what is the sample? It is that last 3 months or 6 months that I have taken. Now, what is important here for this to be a success is the sample the behavior of the sample must actually mimic the behaviors of the entire population. That is very important. That is when you are taking into consideration all the scenarios. An analogy to this is our election results, being election period and all that. The moment we complete everything, we will have these exit polls coming in. Now, what do they say during these exit polls? They talk about samples, and then they say it is anti-incumbency or incumbent will succeed. Now, how do they do that? The overall India population, it is not easy for them to talk to everybody to understand. And invariably, when they say sampling, they ask people and all that. 90% of us, how come that they have not asked me? When did they ask people? Did they come to my booth and all that? Right? So typically what happens here, they will identify how many constituencies are there, and then they will pick one booth at least per constituency. I'm just giving some example out of it. How do I handle the behaviors? So I will pick one booth. Now, how do I pick that booth? That is a representation of all the booths, which means what is a representation for me? Maybe I will say it should have a combination of men, women across multiple age groups, new voters, aged voters, persons with disabilities, a lot of those things. So I will probably pick that sample across multiple. So the idea is when I do this here, that extrapolates in terms of the entire constituency. So that is how they pick all that and then give a sample. Now, is it one booth or 10 booths? Depends on the size of the constituency. Like for example, Uttar Pradesh is one of the highly populated, this thing that has number of constituencies. So there I may probably take two. But let's say, for example, at Delhi, I might probably take a one. So the idea is that is why the numbers don't represent. A lot of times we use a percentage. The percentage of sample pick. We don't say how many samples. We say percentage. So if I say 10% of the population, so every constituency, every booth that I pick, I have 10% strength. And that 10% should not be top 10, bottom 10, mid 10, but it should be a sample of representation of all the behaviors within that constituency. That's what is sample. So this inferential statistics is from a population, I pick a subset, which is what is sample. Now, using this sample, I will do the analysis and then say, extrapolate it by saying this is what happens. That's why I chose the election example. They don't pick all people, but they take a sample. Based on that sample, what do? They extrapolate the results by saying this is what these samples said. So across all the constituencies involved, the result is going to be anti-incumbency or incumbency way. Another day-to-day example that you can probably see is audits. Typically, an auditor, when they come, they say, when they finalize and give the results, this is based on the samples we pick. This is a snapshot. This represents the behavior pattern, but it does not mean that you are perfect in all angles. There could be areas where you need to improve. There could be non-conformances, but that is not seen in the sample chosen. These are words that they use. So inferential statistics is always based on some assumption, and that assumption is called hypothesis. That assumption is called hypothesis. Now, what you do in terms of purposeful analytics is a classic example here because you are picking a hypothesis and then you are trying to prove that to be right or wrong. So that's one way of looking at it. So once I have identified the problem, I will start predicting. I will use the historical data and then say, where am I going in? Like, for example, you will probably say, based on the past pattern, from this department, I always have 10% of the nominated crowd not attending. You always say that you always predict based on that. That's what happens in cricket scores. That's what happens in terms of any sports matches and all that. So that's prediction is not intuition based, but it is data oriented. That is where analytics comes in. And most complex ones of these predictions is where you get into machine learning, where you understand the algorithms, patterns, see how the pattern behaves, and then pick on in terms of what you want to design, how you want to design, and a lot of it. A very mundane example of a machine learning is on your mobile phone, your face recognition. It has patterns. To a particular extent, if there is any difference on your face, be it on your grooming or whatever, it still recognizes because it has a pattern that it has analyzed. Those are codified aspects that you could do. The first three that I talked about, descriptive, inference, and predictive, to a greater extent depends on the statistics alone. But this machine learning depends on beyond, yes, statistics. There are statistical model that comes in, but this is not something that you could achieve out of a basic Excel sheet, but you will start coding related to that for you to achieve. Is that making sense? Any questions, comments? Is it becoming too technical or are you okay with it? Any questions, comments? All okay?
Sir,
Yeah.
I just wanted to request you to touch base on chi-squared test in the inferential statistics, maybe.
Yes, chi-square and all that. I'll probably give you a reference material, Mr. Advani, because if I'm going to get into the details, it can get into a little more of statistics.
Okay.
I will give you references in terms of where you could pick it, and probably that will help you out going through. And if you still have a challenge, I'm definitely available for you to reach out to me so that I can explain. The only reason is,
Sure.
the main reason is because not everybody will probably be able to take in the entire statistical aspects. So I'm just giving a basic this thing. See, in very simple terms, this chi-square test is basically used to see if there is any significant association between two categories. Now, that is where you will probably use a chi-square test. Any significant association between two categories. Now, what do I mean by between two categories? Now, let's say, for example, the Horlicks versus maybe a Boost. Which age group people is having what kind of drink? So, is there any association between age and the product that is being picked? That's one basic example that you could use in terms of the chi-square. That's a basic overview, but I will give you some references in terms of the statistical thing that you can just look at it offline. Hope that's fine with you.
Sure, sir. Sure. Thank you.
Thanks. Thank you. Yes, Mr. Jagannath.
Right, sir. Just like there is a popular phrase we are using, that is reading between the lines. I take this as the reading between the figures. I put this in chat also.
Yeah, I responded saying yes to it.
Yeah, what I wanted to say here, or put my circulation about this, is the wisdom is required to read between these figures. Even though what we have mentioned here, that is about the different types of statistics or tools we may be using: descriptive, inferential, predictive, and what is last one is the
machine learning.
What is mentioned, machine learning. So what I wanted to mean is what inference we need to draw as an organization or as a key person or as a policy maker, and what changes or what modifications or what may be strategical changes we are required to do, all depends on the wisdom. I just want to make maybe little digression for you, but I just want to mention the last week I started writing one article with this title only: reading between the figures, or reading between the numbers. We can say if the figures are word is not proper facing for people, then we can use the reading between the numbers. Just I want to quote one experience. I work for the life assurance industry, life assurance public sector organization. We are always boasting of having the biggest market share in the country, biggest market share in the country. But what is required to read between is what is our core business. And the core business, which talks about what comprise of the total premium, is the individual non-single premium, which is the sustainable one. And if we look at that, then we come to know that it is very, very meager, and maybe the last even among the all compared to all private insurance. So this is what is required. And whatever statistical tools we may be using, the inference that we are going to draw depends on the domain expertise and wisdom of that, what we can say, the concluder who is concluding about it. So that is what my take is. If you want to throw some light on this, thank you.
You are right, Mr. Jagannath. But the only thing that I would probably slightly expand on it is that wisdom with you doing these analysis is no longer dependent on you and your thinking capability, but it is going to be based on the data. Because you remember the DIKW cycle: data, information, knowledge, wisdom. So the data is what you are analyzing. So the wisdom that you get is not based on your brains alone, but the wisdom is based on the data and what the data speaks. So the data informs you something. You consolidate that information to build your knowledge, based on which you get your wisdom.
Exactly. And in one of the HBR's book, that they asked whether your data tells the story. And the story is important, whether it is leading to success or whether it is leading to failure.
Absolutely.
Normally we talk about the analysis paralysis, but I believe in this, that if we do analysis, then we can avoid the future paralysis. Thank you very
Very,
much.
very true. Analysis paralysis will probably become a act if you are trying to pick every relevant data that is available and you start analyzing. You should pick all data that is available to analyze, but you should pick the data relevant to your problem and analyze. That is where the analysis paralysis comes in. But just because I have chunks of data, it does not mean I have to analyze. Where will I analyze? When I have a problem to at hand or when I want to improve something, I will do the analysis. Now, they really want the rest of the data. Technically, I don't want. So if you are spending some time collecting the rest of the data, I don't even need them. I can even drop them. So that's where metrics are also normally consolidated, reviewed, and people drop some metrics, bring it out and all that. When I talk about dashboard, I come to that. But that is where this gets into. But you're right, Mr. Jagna. Makes sense. Anybody else, any other thoughts, comments? So this tick mark is more to say the focus of today's session is going to be this, but your analytics will cover all these four. That's just for your knowledge. So I will get into the specifics on descriptive analytics. What is this descriptive analytics? Very simple. You are converting the data to information. That's what I was saying, DAKW, this thing, so that you are able to understand the past and the current, based on which you will make decisions for the future. That is all. But how do I project it? The data storytelling technique. I'll talk about it in a moment or in a while, few more slides with topics before I get there. But the point is the techniques I use is I could project charts, I could give extracts from the database, I could have tables, I could have summary tables like pivot tables, I could do a combination of all this and then project what I want to so that I convince people in terms of where they have to go. So the descriptive measures that when we are talking about it will probably get into two aspects. We talked about the population and sample. I'm not going to talk. All mobile phone users is a population. Within that could be people who have only smartphones or people who have only Android phones, people who have only iPhones. Those kinds of things can come in as a subset. Now, it is important that when I pick a sample, it has to obtain information to draw valid inference about the population. So your customers who bought Whirlpool washing machine from, let's say, an example of Vasant and Co is a sample of total customer base. But what is important is for the market research, you use a sample to gauge the customer based on this. Right? I've already covered this, so I'll move on in terms of the measures. So when I talk about descriptive statistics, there are three types of measures statistically that we could provide. One is the measure of central tendency, two is the measure of dispersion, and three is the measure of shape. Now, what do I mean by these? Logically, if you look at it, all that this talks about, if you really look at it, is focusing more in terms of the projection. So when I talk, description. So when I talk about measures of central tendency, all that this talks about is from a central point, how is my data distributed? Now, why do you pick average? Now, all of us are used to this average. When you do the training feedback analysis, you will say, I should attain an average of 4 out of 5 on my faculty rating, on my course curriculum rating. All of us are used to putting in these kinds of goals. But believe me, statisticians will run away from averages. They will not want to use averages because they feel that is not the right method. The reason is very simple. 1, 2, 3, 4, 5. When you take these 5 values, the average is 3. 1, 2, 3, 4, and 10. The average probably would be 5. Where is that number 5 here? 1, 2, 3, 4, and 10. There is no 5. When you say 1, 2, 30, 4, and 5, the average probably could be somewhere around 8 or 9. So what happens to the value that are close to your 30, the values that are not so close? So the average, while could give you the way the data is distributed, may not be the right way. The second reason why statisticians did averages, we will say, I would want to reach an average of 4 on 5 for my faculty rating. And then what will you do? Last 10 sessions of the same faculty. 4, 3.8, 3.7, 4, all those were the averages. You will say, take an average of that and say, this is where the faculty rating is, and you will say 3.9. So what have you done there? You have done an average of averages. Average itself is a distribution, and you're picking that and then again trying to see how it is distributing. Is it really providing a measure? So that's the reason why statistics dread. But for us, that's the simplest way to do it. All that I want to know. That's what we do in schools, right? The average student versus an above average student versus a below average student. So it's the most simplest way of identifying how the data is distributed. We need that. While I'm not saying that should not be done, we need that. But it shouldn't stop there. So we get into the dispersion. Now, this is where we talk about some more things like standard deviation, variables, and variation and all that. Very simply, all of us have heard of the term Six Sigma. Now, what is that? All that what we are trying to say is, I am accurate 99.96% or whatever. Flights, for example, can a pilot an aerospace forget to close the door of the flight for takeoff? The opportunity for making an error is disastrous there. So your accuracy level increases. So what you're trying to say here in terms of the dispersion is, what is the range? How do I operate? So where should I move? Even one error can be disaster, that apart. Typically, so on an average, I have scored 60%, but normally my scores are somewhere around 60 to 72. So that becomes the range. So this goes one level detail. It doesn't talk about the spread alone, but it also tells you how is it dispersed. Basically, how are the data going on? And my average may be 30, but do I always get 30? Obviously not. I might get 28, 29, 30, 31, 32, up to 35. So my this thing is 29 to 35. And lastly is where the shape comes in, that will tell you whether I'm skewed or not. I will get into the details in a moment. Right? So basically, when I talk about measures of central tendency, that is basically your location. That is where are you positioned. So it is basically providing an estimate that represents center. The most commonly used is average, but there are others like median, mode, and mid-range. Now, median is the exact central point, right? Mean is basically the sum of all the values divided by the total number of values. Median is the exact central point, and mode, number of times a particular value is repeated, the highest comes in. Mid-range is in a range of say 30 to 40. The mid-range could be 35. That's what we do. So all these talk about the location. When I say dispersion, it is the variation. That is why we call it range, variance, standard deviation, everything. So here, if you really look at it, range will tell you the difference between the maximum and minimum. The mid-spread, the mid-range or interquartile range you say is the difference between the first and the third quartile. Now, this is where your percentile comes into effect. When you say 60 percentile, you are the 60th percentile that comes in, and on an average, this is where. So when you say 97 percentile, you are the top n% and all that comes in. And on this, if you look at it, the most frequently used is a variance, which actually is taking into consideration all the data in question and then gives you a output. I have not got into the formula and other details here. What I will do is I will add some of those references to you when I send this deck, so that you could use it for reference if those of you who are okay to play around with numbers or who are okay to learn statistics. The unfortunate or the fortunate reality of analytics is you cannot shy away from mathematics and statistics. You must necessarily have the statistical knowledge for you to get into. That's where we are trying to give you some aspects around it. That's more for you to understand the terminologies. Correlation. Now, this is something that we do day in and day out. If a particular module can be handled by 4 faculties, 4 trainers, what do? You will try to see who is doing better for what type of audience, and then you pick that particular faculty for that particular kind of audience, right? That's a classic example of correlation. What are the parameters you are correlating? The nature of the audience and the faculty's capability. So you see, this faculty is good for this type of person. Similarly, when we do the content creation and all that, we talk about the different types of learners, like kinesthetic and others. So we try to get into the specifics on for this type of a learner, this is what it is. For that type of a learner, that is what it is. Because some of them may understand image, some of them may not understand, and all that that comes in. So we try to keep that in mind when we are creating the content, right? So this is exactly where we get into. Now, for example, a kinesthetic person will probably know where the based on the movements and all. We talk about all those, like a kinesthetic or an auditory where he tries to listen more. Or when you're trying to talk about your reading, writing, how does he do it versus a visual learner and all that, right? So that's exactly where we move into, and we will pick based on what type of learner it is. That is why most of the time when we create content, we try to align it to all the types of trainer learners so that it will assist. Now, that again is a classic case of an averaging. We make an assumption there up to a particular level, they will all be similar. That is why we make that. But that's the beyond the point. The thing that I'm trying to push in here is more in terms of the correlation. So we are trying to relate these in such a manner that we succeed in terms of the aspect. So we correlate what type of users, what type of it is, based on which we will pick a different set of faculty who will help us in doing these things. So that's exactly what we try to look at. So this is a sample that we are trying to look for. So basically correlation. Now, a very mundane example that we normally talk of in case of a correlation is gold and silver pricing. For example, we always say gold price is increasing, so the silver prices will increase. So those are things. But what have statisticians got in terms of it is, depending on the value of the correlation, they say how closely related or far away are things. Now, let's say, for example, all of us are part of HR. So does experience matter for your salary? Is it education, experience, competency? We look at all those comparisons and then take it, right? All these are classic examples where we use correlation. This is what happens. So you know how thickly populated, how densely populated things are for you to pick on, right? So the last bit, which is your skewness kurtosis, is part of your measure of shape. So basically, based on a shape, you decide what it is. See here. Now, this is a case where it is skewed. So here, the mean is less than the median, less than the mode. Now, all of us are used to this bell curve, right? This is the bell curve, where mean, median, and mode are all same. This is left skewed, this is right skewed. This is negative, this is positive. So if it is negative, there are a few values in data set that are lower than average. But when it is negative, I mean, when it is positive, there are a few values in the data set that are higher than the average. Higher than average, so positive, lower than average, so negative. And kurtosis is going to tell you the distribution. Mesocurtic, leptocurtic, and platycurtic is basically the distribution. This is more peaked than normal. This is not a normal curve. Slightly flatter than the normal curve. See here, your normal is slightly above, so this is flatter than that. And this one is a typical normal curve. This is normal, this is flatter than normal, this peaks more than normal. So by the size, I mean, by the shape of the data, you know it. So how do I do it? I draw these graph in Excel and then say how I could probably achieve the content in terms of your this thing. So that is what happens here. So basically, all that what we are trying to talk about is based on the shape, you say how is the data distributed. Based on the shape, you try to say how is the data behaving, right? So now what I tried to do is I was trying to give you some of the measures, the way we try to look for and decide on how to achieve it as part of your output. So basically, what is the essence that I'm trying to get into out of it? Very simple. All that I'm trying to say is how is my data distributed, or how is the data behaving? What is the relationship between multiple sets? So here I will talk about which is the central point. How is the data dispersing themselves multiple locations. And then here I talk about the variance range and all that, and then move into the relationship between them. And ultimately, all that lands us into what we call as your information. The data is now moving into information for you to build a knowledge out of it and then take the details. So that's exactly where we are moving towards when I use some of these measures. A quick pause here, quite a lot of statistics. Okay, before that, I will probably give you this comparison before I get into that. So the comparison is skewness, kurtosis. Basically, skewness is more in terms of the symmetrical distributions. When it is zero, it is symmetrical. Greater than zero is positive. Less than zero is negative. Kurtosis is zero means mesokurtic. Again, both these, if you remember, the central row is your normal distribution. That's all you need to know. Now, before I get into the data analytics using Excel and all that, a quick pause to understand if things are making sense to you. Any questions, comments, anything that you want to probably look at in terms of whatever we have discussed. Anything at all that you want to bring in? Is it making sense? Any questions, comments? Okay. So now all that what we are trying to talk about here was how are we going to pick on the information for us to take it forward. So now the next step that I'm trying to get into is in terms of how Excel is going to help us achieve all of these. How is Excel going to achieve all of these? So that is the next step that we will probably have to look for, right? So here, what I propose to do is more in terms of trying to talk about a particular package in Excel which will enable you to do a lot of these things. What we call as an analysis toolbar. Now, this is available in all the recent versions for sure. And I think it is available right from 2010 version, Excel 2010. From then on, you would probably be able to have it. Otherwise, we have formulas which we use. I will talk about it in a moment. So basically, you will either use this as a formula or use the wizards to do it. So this analysis tool pack of Excel basically came up from, I think, 2010. I think this came up from 2010 version. Before that, it was not there. It was available only from this. So typically, if you want to check it out, all that what we need to do is you'll have to insert that add-in package for you to get into the specifics. So basically, this is an add-in package in Excel that will help you in terms of getting into the details, right? So let me probably open the Excel sheet and then talk about this section rather than my showing you the PPT. So give me a minute, I will open the Excel and then show you. Just a second. But meanwhile, if there is any question, comments, anything that you want to bring up, feel free to indicate. I will pick the Excel sample itself so that you could probably see it better. Just a second. Just opening the file. So what I'm going to do is I'm going to pick a sample file which has gold and silver prices for the moment, because that will help me look at a lot of those things in terms of the packages that we talked about. So I will probably pick that as an example, and then I will probably give you a perspective of a lot of those aspects that we will probably do that. So that is what I propose to do. So here is the Excel that I have got. Oh, sorry, I'm not shared it. Okay. I hope you're able to see the Excel. Okay, I have just picked some random numbers. I have picked some random numbers for us to get into the detailing in terms of what we look for, right? So I will convert this also. Right now, what do I have here? I have the data from March 97 till March 17, 2017. Some data around gold price, silver price, and platinum price. Now, this platinum price is something that I created, so it need not necessarily tally. I consciously wanted to show it. Now, the data analytics tool pack that I was talking to you about is something that you must probably have it when you want to try it out. So basically, you should see when you get into data, when you get into this option data, you should have this data analysis. If you don't have it, you'll have to go to file. You will have to probably choose options, go to add-ins, and then you will see something called as analysis tool pack. Choose that, and then you'll have to say go for it to come in. Then you will see it, right? So primarily, if this is there, it is wizard-based operation that you work on. If it is not there, you'll have to do it manually. I'll tell you both in the next 10 minutes. So when I use it with the visuals, are you able to see the subscreen that comes in, or you're not able to? Do you see only
Yeah.
Excel? You're able to see the small dialog box, right?
Yes, yes.
Yeah,
Yes,
okay. Thanks. So here, this analysis tool pack, lot of what we talked about is available here. So it gives you everything automatically. See, I had put t-test, your chi-square test, ANOVA table, correlation, all of it is already there. The interesting part is the mean, median, mode, and all that. They also call it descriptive statistics. That is more closer to what we learned now. So let's probably take that. Now, if I'm going to choose this, now the idea behind this is that is this data analysis tool pack enables you to do a lot of analytics. The reason why I'm bringing this or why we brought it into the course is basically because analytics does not need a different tool. A lot of it can happen with the basic Excel itself. That is a message that you need to be clear about. So we thought we will probably get this done. Okay. So this, when I choose descriptive statistics, it'll ask me where is the data, right? I will probably give the entire data that is available here, right? This is my data. Then it is asking me, is it column wise or row wise? It is column wise. So let it be column wise. Does it have a heading? Yes. Now, where do I want to put the new data? I am saying put it into a new worksheet. Now, what is it that I want to see? I want to see the descriptive statistics summary, right? So I say OK to it. There you go. Now, what did you get here? See here, you have your mean. I will probably format it also so that it is clear for you.
Sir, pardon me. What is the version of this Windows? Is the Windows?
Mine is Office 365. This will be available from 2010 version onwards.
Sorry. Hello.
Excel 2010 upwards versions will have it. If you have Office 365, it is automatically available.
Okay. Sir.
Yes, Mr. Jagannath.
Sir, what is your take on the outliers while we are talking about the statistics and these
I'll come to that.
statistics which we have drawn?
I'll come to that. I'll come to that. Give me a minute.
Thank you. Thank you, sir.
So basically, all this what it does here, very simply, all your statistical things that you want to work on, it gives you the descriptive statistics that we talk about is automatically available here, wherein it tells you what is the mean, what is the median, mode, standard deviation, kurtosis, skewness, minimum, maximum race, sum, count, everything. Now, what I will probably do is, if you don't have this data analysis, I know that is where the concern comes in. The first step is mean. So what is the formula that I use? Average. So you have this average, right? So what I will do is for one, I will create it here. So I'm going to say this is manual, right? So I need the average of. Now basically average of what? This is going to be for, okay, sorry, I think this thing is, month is not required. I gave it with the month, so let me delete it and then redo it. Sorry about it. I didn't realize that. So I'm picking this. So my data range is going to be, I would say, data analysis. I'm going to say descriptive statistics. My content is from B. I don't need the month basically. So I will put that and give it. So I have this available. So now what I will do is on this, I will give you the equivalent of the manual. So mean is what we are calculating, mean for silver. So the mean formula in Excel is average. Average of what? Silver price. So pick that entire silver price, whatever you want to, and then give it. It's exactly the same. I will put it into double digit everywhere so that you can. For everything, there is a manual thing. The only reason why we went into the descriptive statistics is because it is wizard based. So those of you who don't see it, you are not missing it. That's what I want to show you. Now, the standard error, I am going to be talking about the standard error in a moment. Now, the idea behind that standard error is basically, there is always a possibility. 5 or 10 minutes this way, that way, I will come there. So that is where you get into, right? So basically, the standard error is something that is calculated as a standard deviation by the range. So typically, if you want to convert this into an Excel formula, you're talking about a standard deviation, the standard deviation of the silver that you probably take, divided by, you will probably use the square root of count of this thing. I will tell you why it is in a moment. It will be minor variations will be there because of the numeric conversions and all that. But the point that I'm trying to drive is for everything, you have the formula also available in Excel. So you're not lost. You'll have to manually remember them to do that. Instead of that, you are doing this directly. See, here we had multiple. So mode multiple and mode single, it will give you multiple or one value. Because I said multiple, it started giving me multiple. So these are all the Excel based ones that comes in. So it will all be there. Standard deviation, mean, kurtosis, everything is available there that you're going to pick on. So standard deviation is actually your STD dev. And then again, the same range that you will probably give. So it's not very complex. Only thing is I need to remember the formula. I need to choose this range again separately for me to achieve it. It will be more or less similar to what we are having as part of the descriptive statistics. Basically want you to understand so much of effort is cut off when I try to do that with a single wizard. And this is something that came in the recent versions, but those of you who don't have it still are not missing it because you're still able to achieve it using the same thing. Right? So I will probably put the formula and then give it to you, but this way I would probably do it. But the essence that I'm trying to bring in here is I will be able to do a lot of these things straightforward when I'm probably using a descriptive statistics and all that. Now, the point here that I'm trying to drive is we talked about descriptive statistics where we talked about mean, median, mode. We talked about standard deviation, kurtosis, skewness, range. All of it is available here. So you will be able to know what it is. And what is not available is correlation because we pick independently. Now I want to choose a correlation. I can probably bring in now let us say, for example, I want to see the correlation between gold and silver. Technically, I will probably use a formula, right? So when I'm trying to use a formula, I will use this formula and then say the two ranges that you want to look for when you are trying to give the comparison for you to create. Oh, sorry. Right? So no point in putting it this way because correlation is a comparison. I'll put it here. Correlation, gold and silver. Right? My correlation is it says 0.954256, whatever it is. Now, this is also available as part of your data analytics tool. You have your formula given this way, or I can get into data. I can get into data analysis. I can choose correlation. I can say OK, and then specify silver and gold that I want. And then I did not choose with this thing. Where do I want the output to be? I'll say new worksheet. See what happens. Now the value indeed is the same as what we saw there. Only thing is you see this one because this column one, I didn't choose a heading. So it's at column one, column two. But typically gold, I will probably, this was silver first and then gold. So it will be one basically because it is silver and silver will be the same. What is matter is for us to look at this. So you have the correlation which can probably be giving you the content here in terms of what you want to do. So the idea behind all this is you are able to do the analysis, your mean, median, mode, standard deviation, sample variance, skewness, kurtosis, everything straightforward in terms of whatever you have seen here. Now, so this is pretty straightforward in terms of Excel. You could probably do that very easily, right? Now, the other thing that you need to understand here, as I said, is your outlier, your standard error, and your confidence intervals. These are three distinct things that one should really understand when we are trying to look at things. Now, the point that we are trying to look for here, if you really look at it, is how are we able to effectively make an analysis. Remember, we are talking about descriptions and all that we are talking about. So when we are trying to talk about a descriptive statistics, all that what we are trying to say here is we are trying to say what has happened. That is the essence, right? So here, what I would have done is, let me go back to the PPT. Okay, so I started off by saying, okay, this is the analysis tool pack. I told you how to, this is a separate add-in. You can use it for all of these. So the basic reason why it is, let's not get into those. I told you, I've given you how to choose that add-in if it is not seen, right? Even after that, if you don't see it, I'll put the formulas here and then give it to you when I send the deck. So I will give the relevant formulas for each of these in Excel so that you will be able to do that automatically. But the point is you need to understand these terms: standard error, confidence level, and outlier. Now I'll go from the bottommost. Outlier. Because Jagannath asked that, I'll start with that. Now, the point here is outlier is an observation which is now coming up when you're talking about measures of central tendency. You're talking about how things are positioned. Remember, I gave you an example. I gave you an example of 1, 2, 3, 4, 5 versus 1, 2, 30, 4, 5. So 1, 2, 3, 4, 5. 5 values, all within a range of 1 to 5. Now 1, 2, 30, 4, and 5. So you have 5 values again. But what is the minimum here? 1. What is the maximum here? 30. But how is the data distributed? When I take an average, measure of distribution. So I'll take an average. 1, 2, 30, 4, 5. You're talking about 42 by 5, which is somewhere around 8-ish. So 30 is not falling within that range of the average that we are talking about.
चश्मे का बॉक्स लेके मैं वो साफ करने का लेंस
It is going far away. It is going far away. So all that what it means here is when it goes far away, what does it mean? It actually means it's much beyond the normal distance. So there is an abnormal distance in the sample. So this is for us to decide whether we need to consider or exclude. Remember, I talked about data preparation in one of the sessions where we talked about filling the missing values. We talked about inconsistent values being there and all that. So that is a decision you need to take here. So coming back to the question on outliers, outliers are those which are not in the normal range. So they are considered outliers. Now, do I take it or drop it? Depends on the data that is available and depends on the modeling that you want to do. And a lot depends on the statistician. Normally, what they do is the outliers are dropped. Normally, the outliers are dropped, but in certain cases where the sampling is very low, they will try to normalize the data and then calculate the patterns. Now, what do I mean by the normalize the data? They will try to, it's like your HR normalization of appraisal. So they will try to bring in a meaning into the value. Now, what is the process of normalization? Make it more comparable. Now, why is HR doing that in an appraisal process? A manager A may be very strict and does not give anything beyond the 3. Manager B is very lenient, does not give anything below 5. But the entire organization has to have a same scale. So they normalize by saying, okay, it is this way, this is this way. A lot of it revolves around the average and all that. That's exactly what we do. So when I say normalize, all that what I will do is I will repurpose the values in such a way that this 1, 2, 30, 4, and 5 will fall within a range. Those are statistical models that we could probably do. While I don't want to get into it, the point that you need to understand is outlier is something which is not the normal distance, which is abnormal. statisticians, based on the modeling, based on the need, based on the volume of sampling that is available, will decide whether to include or exclude, right? Jagannath, hope that answers what your question was.
Yes, sir. What I wanted to ask is after cleansing the data, I mentioned this word in the initial lecture also. After cleansing the data, if the outliers still remain, okay, what you have said, sampling errors and other things after removing all this and after cleansing the data, after verifying it personally, and then if we still find the outliers, like you mentioned very properly about the appraisal of the people, that there can be the extreme things while appraising or maybe while performing also. My intention of asking is that how much importance or how much weightage we should.
Correct. So you are talking about what do I do with these outliers if they still exist, right? So the point is that is where I talked about the concept.
What to do with that?
Yeah, that is where I talked about a concept called normalization.
Right.
Now,
Right. Okay.
right. So what I do is to normalize and make it comparable. There are two techniques that are used statistically. One is normalization, the other is standardization. These are normal English terms that we use everywhere. Okay, but what happens in this case is you are able to compare them more ethically. They are still, see, the point is, do I need those outliers? That's where it starts, Mr. Jagannath. So the point is, even after all the data cleansing and all that, I have outliers. Fine. If my volume of data that I have is say 50,000 records, and there are 5 outliers, I won't mind dropping them. If my volume of data is 5,000 and 1,000 outliers, I may need to worry about it because if I drop all 1,000, will my sampling behavior change? Right? So in such cases, what the statisticians will do is they will apply the technique of normalization or standardization. What you could do is on the net search for normalization and standardization techniques. It will give you the difference. I will probably give reference when I add it. So if you go through that, it will tell you how to normalize. Very simple, mundane example of normalization is divide everything by 1,000, divide everything by 100, so that it all comes to a value that is comparable. Or convert everything to a percentage, so that it is easy for me to compare. That is one way of looking at a normalization, but there could be other things that could probably come in. So that technique is called normalization technique. There is one more technique called standardization. So statistically, we use this for us to get into the specifics. So if you are someone who is working on stats and all that, or who understand maths, you'll be able to get that cleared. You can look at it. If not, connect with me offline. I'll probably explain and tell you how to handle the technique. Right? In the interest of time and the audience profile. Does that make sense to you, Mr. Jagannath? Jagannath. Is it only me for everybody?
I got it. Thank you very much.
Yeah, thanks, sir. Yes, Mr. Ganeshram.
Yeah, you covered a little bit, sir, of what I wanted to speak about. The only thing which I wanted to add on this outlier part is it also depends on the criticality of why we are doing that analytics or statistical research.
Absolutely.
I mean, here probably I wanted to bring in a term of, a reliability engineering when it comes to, say, aeronautics or aircraft landing.
Absolutely.
So even Six Sigma means like, 4 crashes for 1 million. So if outlier indicates there might be a crash at a Six Sigma level, still somebody has to work on that to eliminate that.
Correct. Very true. Very true. You're right. I did, because the moment I start giving into those details, I might have to go a lot of statistics,
No
engineering and all that.
Just in the
That is why I
class,
wanted to stay. No, you're right. I wanted to stay away from a lot of stats, and that's why I stayed there. But you're absolutely right. There is a lot more that gets into that. The reliability engineering itself is a paper for a lot of these people. So there is a lot that we need to go. And as you rightly said, aeronautical engineering, that goes into a deep analysis there.
Yes. Okay,
The other, thank you. The other two we talk about is the confidence level, which means how confident am I? You normally say, right, 5 to 10% variation might exist, but I'm now covered and all that. Let's take the same Six Sigma that we have been talking about. Six Sigmas, we are talking about 99.96% of confidence. So basically, confidence level is the percentage of the possible samples that can be expected to include the true population. Now, that's the technical way of saying it. Very simple way is when I pick a sample and then identify the behavior, how confident am I that the behavior will work in the bigger population? 95% confidence level means, in a more colloquial term, I can make error up to 5%, but more statistical term, 95% of the time, that is when you pick sample from the same population 5 times, 95% of the time, the result will be the same. That is a statistical way of talking. So how confident are you that this will work fine? Majority of the time it will work is what we normally say. Statisticians never say that. They will say 95% of the time, 99% of the time, which means it's not the question of 5% error, but it is a question of every time when you pick the sample from the same population, how confident are you that you will get the same result? I'm confident 95% of the time. I'm confident 99% of the time. That is your confidence intervals. And lastly, your standard error basically is there could be a variation. So variation between the population and sample, we could have probably done that because we are choosing the random sample, and how is the randomization done is where you'll have to manage. So the sample distribution should mimic the population standards. So all that what we are saying is, now when I pick, now let's say for example, the same confidence level I'm getting into the other aspect, every time when I pick the sample is what I said. Now, when I'm picking the sample every time, first set I pick 5 samples. Are those 5 samples eligible to come in the second time or not? That is, are you able to handle it with or without replacement? So what happens is every time when I'm trying to do a with replacement versus without replacement, the average changes. If it is a without replacement, the number of values reduces, so the average changes. So when I try to balance this, there could be a minor difference that could potentially come in the accuracy of the data. Though my confidence level is 95%, I might slightly vary from that, and that is attributed to what is called as a standard error. Right? These are terms to know. You don't have to really get into the details. The reason why I'm bringing in probability is more because most of your analysis is based on probability. You always say that, right? Normally, I will be on time, but there could be 1 or 2% time when I may not be there. Similarly, when I start from here and say I will reach there in next 10 minutes, subject to traffic. So the probability of the traffic being heavy versus not heavy is where you are dependent on. So very normal mundane examples of probability is your toss of a coin and all that. So when you toss a coin, you have a head or a tail. When I ask for a head, what is the probability of getting head? There are 2 options, head or tail. So 50% I will be successful. This is very simple because it is head or tail. When you have a sample of 500, what is the probability that your data is chosen for the sample? 1 out of 500. So that way we start looking at it. So simply put, if something is impossible versus certain is where you get into. It is a likelihood, it is varying between 0 to 1. And the terms that come across in terms of the probability is experiment. That is, you are basically trying to check what could be the reason. So you'll roll the dice multiple times to decide what it is. Or you are doing a market research and all that. Outcome is the result that comes in. So market research says I am okay to introduce a new product or not okay. That is the outcome. Sample space is what is the sample that you took. Event is the occurrence of the event. That particular research or the roll of dice is where the event comes in. So typically, probability can be subjective, classical, or relative. Basically, all that it means is how are you trying to apply? Subjective is based on a judgment. So sports experts might predict at the start of an IPL, 1 in 5 chance for a team to win. Similarly, for if a classical, then it is more in terms of generating the outcome. So you're talking about a tossing of a coin. So you're clear about the outcome. The relative is a combination of this. It's based on past data. A lot of our analytics will fall under the relative frequency is where we get into, because we are talking about multiple outcomes that could probably occur based on which you're picking on. So the reason why I brought probability is because the entire chunk of analytics revolves around collection of sample data to understand the distribution and then use the tools to construct the distribution as a histogram or whatever the descriptive statistical measure that you are trying to use and extrapolate it for you to achieve. This entire process is what is called as a data modeling and distribution fitting. Right? This is the essence of your analytics. So I talked about data modeling. So what is it? It could be a mathematical descriptive property basis that you are giving, wherein you are trying to give the trend and all that, or you will probably position the data what is available to showcase where you are. So you're slowly moving into the concept of data storytelling. Now, before I get into this data storytelling, a quick pause to check if things are okay for you, anything specific that you want me to look for. I know it is slightly a heavier session than normal because I had to cover a bit of statistics here. But here on, there is no statistics. We are just going to talk about the generic aspects. Any specific questions, comments? Is everything fine? Okay. So the next is data storytelling. So what is data storytelling? It's normally known as the last mile of the analytics. You do all this and then you'll have to present, right? And that's exactly where storytelling comes in. It's a combination of data, visuals, and narrative. These are the three distinct elements that you need to basically use. So you have taken a data. Where did you take the data from? A particular population, a particular sample of a particular sampling need or sampling criteria. And then you project the data. Now, visuals could be table, visuals could be charts, visuals could be anything. But you're trying to build those visuals based on which you're narrating your inference. That is what is data storytelling all about. So visuals make a big difference in your data storytelling. So when I talk about visuals, normally they talk about scientific information and visual analytics. A combination of these three is required for any visualization. Now, what is this scientific visualization? This scientific visualization, if you really look at it, is the concept where you are trying to graphically illustrate the patterns. Now, when you draw trend analysis, for example, we have lines going up and down. So you know how the trend is. That's a good example of scientific visualization. When I talk, but the same thing, what is it saying? It indicates how the data is formed. So that becomes an information. So you have a histogram, trend graph, and all that. So you're visually trying to showcase. So a data visualization is a combination of scientific visualization, information visualization, and visual analytics. So that you are able to project a complex outcome in a much simpler term than what you wanted. So normally we do that, right? Images tell you a lot more than text. That's where the visualization comes in for us. That is because the combination of the left brain and right brain comes in, and a lot of people say visualization enables you to make the right brain work and all that. While I don't want to get into the science behind it, the point that we are trying to look at is data visualization will help me understand better on one side using my left brain in terms of image colors and this thing and contents with the right brain. So I'm able to consolidate these to get it. So in simple terms, I'll be able to understand things better in terms of analysis and be able to make judgments. That is where I come into. So what do I need? Definitely maths, a bit of algorithms. You don't have to learn algorithms, being training teams. Your basic averages can take care of it. Your mean median mode can help. Your standard deviations can help and all that. You don't have to get into k-means and all those kinds of statistical models. But normally visualization output will be an effect of these. Data cleansing we have seen. Design aesthetics is more in terms of how you want to present your graph and all that. So obviously you'll have the graph, text and all that. So how do you do that? So a visualization will incorporate all these together. It could be simple Excel charts. It can be based on some interactive tools like your MS Power BI, Tableau, ClickView and all that. it doesn't matter. But what matters is how are you projecting it. So the essence of your analytics will form from the perspective of the data collection, where you understand the need and ensure the data is available. Then consolidate the data. You take the data from multiple data sources. We saw that earlier. And then dice the data the way you want it and the way the audience will expect. That's your analysis. And finally, build charts and tables, that is your visuals, for you to present. How do you present? Using dashboards. So basically, what is a dashboard is what I will start here on. Just give me another 5 to 7 minutes and I will close it. I know we are just reaching on at 11:30, but give me another 5 minutes, I'll close it. But before that, what is a dashboard? We see that in a car. What does it say? There are certain images. So based on that, you go open the bonnet for you to check whether things are like suddenly you have that heat coming in, you go check whether the coolant is available or not. Suddenly the battery light is not switching off, you know the battery is a problem, you go check. So basically, dashboards are those visual parameters that will enable you to focus in terms of what is it that you want to analyze. So it is basically a visual display of the data. It gives you all the data, it picks visualizations based on all the data that is available. The idea is to give you a at a glance review. You drill down to get into the details. More importantly, it is more real time, and it gives you a 10,000 feet level outcome. And if you use tools like Power BI, Tableau, and all that, you can make it more interactive. Basic interactiveness is possible with Excel. You could create a filter, slicer, you could ask people to choose based on slicers and all that. That could probably help you. Right. Now, the purpose is basically, as I said already, similar to your car control, the speed, fuel, temperature. I'm trying to do. Basically, I need to know the pulse of the outcome. So for a training team, what could be the pulse that is required from a training team perspective? What are the key things that I will look at? Very simply, I'll be talking about in terms of what are the things that I look at. I will talk about number of training programs. What is the average this thing? What is the support I get in terms of nomination versus attended? So I get into those kinds of things, and then I get into the detailing in terms of how we will probably do that. So that is exactly where I will probably use it, right? So this is how I will get into the specifics in terms of what we are trying to look for. So the key factor that you need to keep in mind, these dashboards are simple ones which will enable you to go deeper in terms of your need based on how the behavior of the data, right? That is where you will probably get into the specifics. So that's exactly where you will probably get into the detail, right? So with that said, what are the different types of dashboards? Now, normally the dashboards are of three types. One is called operational. Now, when I say operational, this focuses mostly on the metrics that we capture. Lot of our training dashboards are operational dashboards that we probably look for. So basically, it tells you how the operation is all about. So basically, it will give you what is going right, what is not going right, how are things going on, and all that is where it comes into. So it is more descriptive. It is basically giving you the operational data. You could make it look more realistic, real time, and all that. Of course, realistic, but you can make it more real time and all that, which is possible. But the essence that we are trying to look for here is this is all taking the operational data and providing, right? Now, when I talk about the second one, analytical dashboard, now here, the analytical dashboard basically focuses more on comparisons. You talk about trends, you talk about past versus present, and then take it. And strategic will more in line with how do you want to change things so that you are achieving in terms of what you wanted to achieve. So those kinds of things will probably come in, and that is where you will use this. So this is how you will probably be doing it. So those are the analytical, the dashboard concept that comes in, wherein you could use the analytical tools, or you could probably get a basic Excel for you to achieve. Now, I could probably draw this thing in terms of inference, in terms of how you want to do that by getting into the details. Normally, organizations start with operational dashboard, over a period of time move into analytical, and then when this knowledge evolves into a wisdom is where we will get into the strategic dashboards that come in. So it is all possible with Excel. Let me share another screen and show you a sample Excel dashboard itself, all done in Excel. See here. You have this data. You've got the data here. There is some amount of data that is being provided. Now using this, I'm talking about a basic operational data. So I'm talking about revenue versus actuals versus the target, the graph related to it. New customers, actual versus target, customer acquisitions, your revenue target. So all these are, I've positioned it and I've repositioned it in such a way that it looks like a dashboard. But where it is not interactive is I may not be able to, even if I'm looking at this, I may not be able to filter it, pick and choose what I want, where to change and all that, which is where I will have to. Like this is a conditional formatting. This is a graph. This is an accumulation formula that comes in. This is a text that I'm putting in, but I'm making it look like a dashboard. This is a very simple operational dashboard sample, but you could do a lot more in terms of how you want to do. Now, this is a conditional formatting. See here. This is how you have put in a conditional formatting wherein you are saying how you want it. When the value is greater than or equal to 95%, you say tick mark. Greater than or equal to 80%, you say this exclamation mark. Otherwise, you say when it is less than 80%, you say into. So that is how it gets into this. Like for example, if for some reason I will not put this formula, but I will say 9%, it automatically changes because it is okay. Sorry, 0.9 will be 1%. So it automatically became an into. That is where the conditional formatting comes in, right? So it is up to me to decide how I want to take it. But all this is possible using an Excel. That is the essence that I want you to understand. Excel is good enough for us to do most of the operational dashboards, to an extent analytical dashboards, because you have your correlation and regression also coming in there, which could probably help you out in getting those things done. So that is the essence that you need to keep in mind. But how do I do that? Basically, I need to understand the purpose of the dashboard. I need to know what are the KPIs to track. Now, if you really look at it here in this Excel, I know I wanted to compare these as the KPIs, revenue target versus actual target, new customers versus actual versus this thing, customer acquisition cost, average revenue per cost. So these are the KPIs. So I am projecting it. So the essence that we are trying to look for is I need to know what is what so that I will do it. The second point that you also need to know is more in terms of the nature of audience, your audience. What is your audience profile? That is very, very important because they are the ones who are going to look at your data. So you need to be able to give it appropriate to them. Now, the second reason why that becomes important is these days, gone are the days when we prepare a deck and then present it together. But today we are sending it remote working and all that. So your data should talk the language that you want it to talk. Whatever the purpose that you created it, they should be able to see it. So it's very important that you understand the audience. Is it really complex to do a dashboard in Excel? No. Just get all the data into an Excel. It could be multiple sheets or single sheets. Analyze the data, put in all your pivot tables, conditional tab, formatting and all that. And then create a dashboard tab and put everything together. And that's exactly what I have here as a sample. See, you have the data. I have done all the analysis related to the data. See here, Q1, Q2, Q3, all those information is already provided for here. All that what I'm doing here is, this is a very simple one. So I calculate with a formula. So the formula is all established. The graph is all put here. And then you position it and repurpose it so that you will probably be able to achieve the look and feel of a dashboard. So theoretically, a lot of things can be done using Excel. And that's why we want you to get into the detailing in terms of dashboard using Excel, because not all organizations will get into a full-blown data visualization tools, but every organization has an Excel. A lot of you would have used Excel, but I know for sure some of you would start thinking, I didn't realize I could do so much in Excel. Can I not look at it this way? Can I do this? Can I do that? Is something that you will probably come across, right? This pretty much summarizes what I wanted to cover, and this completes the content syllabus perspective. As always, let me reiterate and tell you what I have done is a practical application of the concepts behind the L&D analytics in the 5 sessions. This is only an add-on to your book that has been given, the study material that has been given. That gives you a lot more detail. I didn't want to repeat what is there in the study material, so I've given you the concept and the application. Beyond this is something that you will have to probably apply this in your thing. So the way you could probably do is, you already have data, you are presenting reports and all that. So what I would suggest is, take that data, rethink in terms of the concept of a dashboard. What are my critical metrics? What is it that I want to position? How do I want to position? Use your creative mind and then put the structure. You see the difference in terms of how things come in. You could do a lot with Excel. You could do a lot with the kind of data that we consolidate. Training team has a lot of data. HR team has a lot of data. And there are a lot of opportunities to collect a lot more data. So you could probably be able to do it, right? With that, I complete this content. A quick pause to understand your thoughts or comments, and any questions I can answer. And let me extend on this. All of you have my number. We are all in a single group, thanks to STD. Otherwise, also, I have given my number in my data. So you could always connect with me and get your questions clarified. My only request is, this number is both WhatsApp and phone. So send me a WhatsApp message, because I may not have all your numbers. So if you have any questions, just send me a WhatsApp. I will probably tell you when to contact. If I'm available immediately, we can reach out immediately. Otherwise, we'll schedule a time and discuss. But I'm always available to support you. I will pause here. Over to you for any questions, comments, anything that you want to bring about. Anybody?
Thank you, sir. Thank you very much.
Most welcome. Yes, Mr. Advani.
Yes, sir. So just one quick question on regards to the data analytics when we are preparing for our exams. Particularly, how do you suggest we look at that paper? You know, like in terms of the questions being asked regarding data analytics, any particular topics that you would recommend?
I wouldn't suggest topics per se. Couple of things that you could probably look at is, look at the past papers, obviously. If I were to prepare the question paper, I will make it more case study based. So I will make you look at analytics. So I will probably give you a data, ask you to analyze as one example. You might have to look at some of the definitions. You might have to look at the concepts. But there is no important questions or important topics, because the way this paper has been structured, it tells you why is this data important to all the way up to how do you use the data. So a lot of the questions would ideally be from how you will apply that knowledge. But be assured, they're not going to ask you questions on Excel sheets, but they might probably know, if you really look at your course material, especially the last topic, which talks about a lot on the tools for analytics and all that. There are some aspects of that which covers details more in terms of what are the tools, how do I do it. They have talked about a lot of these formula, the quantitative data, qualitative data, and then they have tried to tell you what is a measure of central tendency dispersion. Formulas are given. They may, for short answers, ask formula, but a lot of it is going to be more on the concept and its application. That's how I will look at it.
Okay, sir.
The best thing is for you to look at the past papers. Those are available anyway for reference.
Okay. Okay. Thank you, sir. Thank you so much.
Most welcome. Most welcome. Anything else? Anybody else? Hope these 5 sessions were useful. You get a grasp of what it is. I do not know whether you had time to go through the material as and when I completed, but as always, you can reach out to me. Yeah, Mayuri.
Sir, no questions, but just wanted to thank you for all the sessions. I think they were really, really insightful and learned a lot, especially, sir, your presentations that you showed us. I think they were very beautifully done. And that's also one learning that we got as to how to do our presentations. Thank you so much.
Thank you. Thank you, Mayuri. Thanks for your kind words.
I would like to thank you because whatever Mayuri said, it's true. The visually, whatever the presentation you did, those were really visually appealing and very attractive. And whatever the information and knowledge you have shared, that is with the highest extent. So thanks very much for all the value you are adding in
Thank
all
you,
of
sir.
this.
Thank you, sir.
Yeah,
Thank you,
thanks
sir.
a lot.
Thank you.
Thank you.
Thank you very much.
Sir,
Thank you.
I do have a
And I think
question.
the good part is
Sir, is
the
it possible
presentations
that
have
we
been
can
shared.
have a revision
1 minute.
class?
1 minute. What is the question, Tia? Tell me again.
Yes, sir. Sir, is it possible to have a small revision class as well?
Check with the ISTD. I am open. I will also tell them that you are requesting for. Check out with them, depending on the
Okay, sir.
availability of time, because then you'll have to cover everything. The exams comes in and all that. We could do it. But
Yes,
what
sir.
do you expect out of the revision class, if I may ask you?
Sir, because I seem to have missed one or two classes. Other than that, sir, because it being such a technical subject, it will be nice to have just a small revision with you because, sir, you explain so well. So, everything that we've learned will get consolidated just before the exam,
Fair
which
enough.
is what, yeah.
What I would suggest is go through. I've anyway shared all the material of all the classes. Go
Right,
through
sir.
it, and if you have any
Okay.
questions, reach out to me,
All right,
irrespective
sir.
of revision class available or not, depending on the timing. As I said, you can reach
Okay.
out to me and I'll help you out.
Okay, sir. All right.
Before I
Thank you
come to
so
you,
much.
Mr. Advani, Jagannath, you were saying something when Tia was talking. You can probably say that and then I'll go to Advani.
No, I said good part is that you share the presentations immediately. So that is much more appreciable. Thank you very much.
Thank you, sir. Thank you, sir. Yeah, Advani.
Yeah, sir. I was just like, as Tia was just requesting for the revision class, and your question was, what would be the takeaway from the revision class? I would have just probably put some emphasis on, probably doing 1 or 2 case studies, just as an example. That's all.
Okay. I will see if I can do that. You can also
Yeah.
check with ISTD.
Yeah.
I
If
will
time
see if I
permitting,
can
sir,
do.
time permitting.
Yeah,
If
yeah.
it's possible, then it's okay. If not, then,
If what we could probably do is check with them, or what I will do is give me some more time. I will add a case study to this, and then I will send this material today as it is, and then I will create a case study. If you notice, every session I have had a case study directly given. So what I will do is I will add another case study where I will probably pick a scenario and then tell you what is the data available, how we are presenting it, how we are taking it, how the output is. I'll probably create some this thing and then give it to you in the
yeah,
I'll
that'll
prepare
be,
it and give it to you. That should not
yeah,
be a problem.
yeah, that'll be great, sir. And then maybe, like if you can give, like some time, then we can have like a little discussion
See,
on that. That's all.
you
It's
can
all
reach out
entirely
to
up to you.
you can reach out to me.
Entirely up to
You
you,
can
sir.
reach out to me anytime. You can
Sure,
reach
sure.
out to me anytime. That's not an issue. What I
Okay.
will do is instead of building it as a case study and all that, what I would probably do is pick some numbers, create a dashboard in Excel and give it to you. Because the point that I am trying to drive what here is the combination of you trying to read the data, build the metrics, and then create a dashboard. So I'll probably create an Excel dashboard or try to pick some Excel dashboard like what I have given here with some information and then send it across to you as an example. So you will
Okay, sir.
know how things have come in and then see how you can apply it. And then we can connect in terms of, see, if you have any questions, I'll probably expand on this.
Yeah, sure.
While you may
The-
look at revision exams and revision session and all that, I would probably say as a group, collect the questions that you have. And if you think we need to sit together to understand these questions, I'm available for you so that all your queries can be clarified in one session together. I'm
Sure,
open.
sure. Definitely. So I'll also reach out to you. No
Because
problem.
a lot of these batches, what they do is, while revision is difficult considering the way the timing is structured for your exam and all that,
Correct.
one day before the exam, most of these people form a group and you study. So most of them will have the set of questions. So they'll connect with me. The day before the exam, they'll clarify all those questions. I have done that in the past and I can do that with your batch also.
Thank you, sir. Thank you.
That is more closer to the reality rather than expecting some revision sessions and all that. That's my thought. Though I'm open for revisions. too.
Agree, sir. Agree. Thank you.
Anybody else? Anything else? Okay. Thanks a lot. Thanks for your time all these 5 weeks. I think most of you attended all the 5 sessions and thanks for that time. Hope this gives you some value. And more importantly, today was the longest of the session and the content was also heavy. Thank you for your patience. All the best. feel free to reach out to me whenever you want. I'm always available. If I don't pick the call, please send me a WhatsApp and then I will respond to you. Right? Thank you very much. All the
Okay,
best.
sir.
All the best.